And we're going to have a little discussion now about what you do as the chief of the Laboratory for Storage Architecture and Systems at CEA. That's probably not a great translation from the original, but roughly you run storage for CEA and have done
Yeah.
a lot of things. Why don't you tell us a little bit first before we get started about what CEA is and what the mission is there?
Okay. Actually, CEA is a French alternative on Atomic Energy Commission. And it's quite a large company in France. It's more than 6,000 people.
Okay.
And it's a key actor in research and development and innovations. Since as a major actor of the science community, especially handling most of the things related to the atoms, he is operating several compute centers, such as the TGCC, which was deployed in the PRESH initiative with machines such as the Curie machine and its successor, the Joliot-Curie machine. Among with supercomputers, you need storage, and it's a large aspect in the modern compute centers. And we have been working with DDN arrays for more than 15 years, I think. Starting with the first SFA arrays, we have been using a product from DDN, and we enjoy the reliability and the way it can be integrated into the architecture we are using, in particular for running large parallel and distributed file systems such as cluster, which is a very key element of our storage architecture.
Tell us about the breadth of workloads you have. I'm guessing you have big parallel, sequential, well-behaved workloads, but you probably have everything else as well. Can you break it down into the characteristics of the workload groups?
It really depends on the kind of application which are running on the supercomputer. You have, I would say, you have two kind of application. You have those who are aware of the storage. They know that they have a very efficient parallel file system behind, and they know how to handle very large files. And they know how to optimize their architecture so that when they're performing I/O operation, they can benefit from the parallelism offered by Lustre, then by the network, then by the multiple network adapter providing on the disk arrays. On the other side, you have applications that do not know at all that, and they are making millions of small files. That's not that nice. Yeah. I prefer when the files are big and when you have very good performances, and when you have inside the simulation code, you have a middleware, which is actually providing the optimization for making the I/O access.
Yeah, as we were talking about, Andreas was talking about earlier, there's various aspects of the file system which is basically our attempt to not have expectations from the application developer. So to deal with small files, or to deal with wide striping and have progressive file layouts and all this kind of stuff. How much do you use these techniques in the file system to optimize for basically bad application behavior?
Currently, we are currently in the process of deploying this kind of stuff. So recently we acquired a system which mixes HDDs and SSDs, and we use them as different pools in Lustre, having machines do the data movement from the SSD pool to the HDD pool based on policies and migration policy using the Robin Hood software, which is developed on the side and which is available as an open source software, and using it to select the file which are good candidates for migrating from one pool to a lower tier. So we are currently in the process of start using the progressive file layouts feature. It's still a work in progress. It's a very promising feature. We are afraid of finding issues if we put a heavy pressure on it. So it's something that will be in full production in a 6 months time scale, no later than that. Once we have do heavy stress test and make sure that everything's okay.
Yeah, you bring up a good point there, which I wanted to raise, which was around, in the market, we see some vendors really saying it's all flash now, HDD is dead. And we have some vendors saying it's a hybrid world for some years to come. What's your view in terms of the longevity of HDD at CEA?
Actually, for more than 20 years, I've also heard people telling tapes are dead, use disk for backups. And every device, every storage media has its pro and cons. In the forthcoming years, in 10 years, I'm sure we'll still have tapes. We'll have HDDs and we'll have SSDs and even faster devices such as NVRAM, which will probably have more importance since it will become cheaper in the next year. So what architecture should be aware of is making using the right resource for the right use. And it brings to a very complex issue that will be to be dealt in the next year. And from my point of view, that's one of the major exascale challenges, is the data placement. If you consider a simulation card, for example, you have checkpoint restart object, which are files, which I called warn file, because they are write once, read never.
Yeah.
And if you can produce that kind of data in the lowest level of the hierarchy, eventually directly to tape if possible, that would be nice. But you have some files which are intermediate result file, which are accessed quite aggressively in the simulations, and it makes sense to have them using resources on expensive media and very fast media, such as SSDs or NVMe resources and this kind of stuff.
Yeah, we've been developing, we talked about a little bit, this technology called hot pools. And the idea is there's quite a large layer of flash and an extremely large layer of HDDs, but it's all managed in a single namespace. And basically behind the file system, we watch for the heat of the files. And we just sit in the background and we move hot data into flash and take cooling data into drives. And it's a background activity. So the tendency long term is that the flash tends to be populated with the hot data, and the HDDs tend to be populated with the cold data. Now, it doesn't work in every use case because sometimes the data access is really super random across a huge data set, or there's no so prefetching doesn't really help. How might that kind of model work for yourselves?
I think it's a promising model that will work for most use cases. The point is, how do you measure the temperature of the file? Is hot data something you access very frequently, or is it some data with a critical importance for something you cannot lose? So it's more a matter of having the right metric with the right usage. And definitely you have that important data, not that important data, or garbage data. Data that you can, some data are like milk. After a few days, it's better not to consume them. And that's the same kind of idea. So it's you have to use your data with metrics depicting how important they are, how hot they are actually, what's the temperature, what temperature they are.
No, absolutely. And the method we use today for file heat is there's two options. One is just how often is a file accessed, and the second one is how often is a file accessed divided by its size, because that second one means you don't move. So large files which are good at sequential I/O, they can kind of stay in HDDs, whereas small files tend to be hot and they go to the SSD layer. But it's still, we expect to gradually increase the amount of intelligence around calculating file heat, and also, of course, to have end user inputs to say, please keep this important file or data set in flash. So those are being added, but we've always expected to gradually evolve the intelligence of file heat, try and optimize this placement.
I think it's quite similar to cache eviction mechanism.
Sure. Yeah.
If you look at the very first cache, you had very easy, very simple LRU mechanisms, and you had the ARC mechanism, which is a more elaborated LIU, and then the more the year we're passing, the more elaborated cash eviction method you get. So that's kind of the more we will be considering that matters, the more we will be aware of the various facets of that problem, which is definitely not an easy one. The more we will get elaborated method to handle it.
Hey, let's talk about security. It's been one of the themes of this this little summit, and it's something that we believe is going to be very, very hot. You know, even today, it's obviously important, but I think the relative importance of securing data and all the different aspects is growing. I'm assuming that CEA has quite a strong process when it comes to securing that data. It sounds like it quite important. Can you tell us a little bit about the challenges you have around securing the data and what features you need?
Actually, when speaking about security, you have very different levels. You have the security of the walls, the place where the installation resides. So having good logs, having security with people checking access permission when the actual person go to the computers where they can access the data. That's part of the security. Then when talking about computer security, then we have a major concern for mostly making sure a user is the person is supposed to be. So just reducing the security issue to an enemy within issue. So the person who can do bad things is actually someone who has the right to access the data, but who has been corrupted. And the better way then to handle that is to make sure that you have records about how the data are used, which can be done by the changelog. If something occurs, you can do a post-mortem analysis of what was done and find who's guilty. And you have to make sure as well that the users can only access the data they need to access. Right. If you have a neurobiologist on one side of your compute center and you have a weather forecasting people on the other side, it doesn't make sense if the weather folk can access biology data. It doesn't make sense. And so it's important to isolate the data inside containers at a software or even hardware level, and make sure that those containers are hermetic and that the data can't escape easily from them.
Yeah, so we've been working on this a lot, and I talked a little bit about it in my presentation, but for a while within the Exascaler file system, we've had multi-tenancy, which allows us to bind subdirectory structures into specific tenants. And then just now in July, we'll launch Exascaler 6, and that's when we've brought in the client-side encryption. So that allows us to have either individual user or tenanted encryption over the wire. What do you use today? I presume you're using at-rest encryption rather than...
For accessing the file system, we do not encrypt them.
Okay.
It would result in a very massive loss of performances, and we do not do that for the moment. But once you access the compute center, you have passed a set of gates. Even if you connect from your office to the GCC via SSH, we have a strong security methods.
So Philippe, I have an interesting question for you about how difficult it is to manage large storage. You obviously have a team of people. This has been something that required a lot of academic excellence over time to set up and run. How's that evolving for you?
So recently we had some movement in the team. So I had some people left and some new people have joined the team. So we're in the process of teaching the new ones to get the method from the previously established people. It's storage management. Basically, we have different sides. We have the software management. We have the hardware management. Software management is handled via the control of the installed software. We mostly rely on open source software, such as Cluster, and we really do not like to go to vendor locked solution. And the fact that we are part of a system which are black sites doesn't make easy to have a vendor. We cannot send logs to vendor. It's not easy. We cannot have people from a vendor coming to the site and making on-site analysis. So we have to do this analysis by yourself. And sometimes we have to use the debugger and look at the Lustre sources and be aware of what the code is doing at what part, and analyze the crash, which results in some situation, and then do the post-mortem analysis. So we need to have a very deep knowledge on the way the product is working and how it interacts with the hardware. So good point was DDN hardware such as the SFA is capability of unbending the virtual machine inside the disk array, making it very close to the disk. But we can do a kind of an appliance which embeds the software we compile on it.
And so James, I know we had just talked about some of the management improvements and initiatives you guys are bringing along. Do you think these are going to help Philippe here?
Yeah, so CEA have had a long experience in using open source tools. What we've done is, this new set of customers, particularly the sort of huge growth we've had in AI, they're really demanding an out-of-the-box simple method. So we've developed this management framework called EMF, Exascaler Management Framework. And it's really, so at its base, there's a stateful database which knows the current state of a cluster. And on top of that, we got a mesh, which is coordinating messages and allowing little micro jobs to go and upgrade server A, upgrade server B, and get the response and requests out with that. And then that's all pushed into a CLI and API and user interface. So it's all very, very fast. It's very, very scalable. And essentially you can plug that into other systems like Terraform can just leverage EMF and ask for a cluster. So essentially this is to coordinate large scale upgrades across big clusters. I mean, it also start small, but do all these shapes and sizes. So that'll be available. And as I say, we've been careful to keep it integratable with these open source tools. So open source tools just leverage EMF if customers have been embedded with those tools.
So basically, regarding the maintenance, different policies are used. The supercomputer guys, they can shut down part of the machine, upgrade it, then restart it. And for a given time, they will have a smaller supercomputer. You just have to tell Slurm that some partition are done and it's okay. So they can perform permanent on-the-fly maintenance. Regarding the storage, it's not that easy because once you have shut down the file system where any data resides, the user can't work. And it's quite hard to do that kind of maintenance. And dealing with the upgrade, dealing with this kind of stuff, usually we have a long tradition. It's a little old-fashioned, but we have a long tradition of scheduling day of maintenance, where everything is shut down. And the users know that when there will be such a day. And we engage ourselves not to overcome that duration. So we say the compute center is stopped for a day, and we do not stop it for 2, 3, 4 days. It will only 1 day. And we plan this operation for the maintenance time very precisely, so that we can perform all the upgrade, on the improvement, on the integration of new hardware and things like that at the time of those maintenance days.
Yeah, so when you upgrade to the latest version of SFAOS, you'll start seeing some very nice surprises there. So we put, in fact, 18 months of work has been gone into speeding up the upgrade process and allowing it to happen online. So lots of parallelization of the various upgrade tools, lots of simplification of the processes at the back end there. So it's light years ahead of what it was 18 months ago, the way we can upgrade these SFA systems today. Big improvements from 11.9.
Okay.
Hey, Philippe, maybe we can just have one last question. So we've covered security, we've talked about hybrids. Can you give us just maybe an insight into your three, or the top 1, 2, or 3 challenges outside of this scope that we've already talked about?
Well, actually, I think that everyone in the supercomputer domain is speaking about the exascale, and when talking about the exascale, if you consider projection from, for example, the NLSA, who did publish stuff a few years ago, if you consider, for example, a 10 exaflop machine, which is something that is reasonable for the maybe 2024 or 25, then such a machine will have tens of petabytes of RAM, only RAM, which means that on the storage side, involving both disk and tapes, we'll have to manage up to exabytes of data. And at that point, I am afraid that the model we were using, such as parallel file system, available on the whole of the compute machine, will not fit the need. And for breaching the exascale, the vendor was successful in designing machine with more memory, designing a processor with more core, with more power, compute power, and so on. And I guess the next barrier is the storage. We have to have a storage capable of handling with that exascale challenges. So I guess that new paradigms may probably be to be found, and I am trusting a lot the object store approach, which scales very well to a very large and distributed architecture. It doesn't mean that we will get rid of the old-fashioned way of working with file system and POSIX interface and things like that, but maybe there will only be considered as interfaces, end users interfaces. So such as a simulation code may say, I am a simulation code who needs a POSIX interface, or I am a simulation code who needs an S3 interface to fetch my data, or I am using this middleware which handles all of my I/O operations, so make your system capable of interacting wisely with my middleware. So that's the first point. And since the data architecture will become will require more storage, but as well more performances, that definitely means that we were heading towards a tiered architecture involving NVRAM, such as 3D X-Point, involving fast SSDs and HDDs and tapes, and we are sure that we will have this tiered architecture with many levels, and the movement of data, the promotion of data from one level to another, the demotion of data once it becomes colder, actually, rise up the management of the data placement. And I guess one of the key elements of the future of the architecture of the storage system is placing the data at the right location.
Yeah.
And that's really a critical challenge to deal with, and it will become even more crucial to solve, since I guess that the amount of data will explode. We will probably not have more files, a few bigger files, but lots more files.
There's definitely more to talk about there. And actually, if you wait till the end of this year, we'll be talking a bit more about our next generation software, which really does hit quite a lot of those challenges on the head. So more to come. Watch this space.
Yeah.
All right. I think with that, we've got to turn to our next discussion here. Thank you so much for being here, Philippe, and answering our questions and chatting with us about a real world usage of Exascaler and what you guys are doing. It's really exciting. And with that, James, also thank you for being here on our discussion, both some of the features that you presented before and now with this discussion with Philippe. It's been great talking to you again, and I hope we get to talk again soon.
Yeah, and you, Mike. Great stuff.